Hey everyone, how's it going? In the previous video on this channel, I showed a way you can make custom items that move with the player without being laggy. The only drawback was that it would not work in multiplayer. Since then, I have found out how to make it work, and that is what I'll be sharing with you today. Before we begin, I'm issuing the same disclaimer as before. This is not a step-by-step tutorial, however, I will be going over it in greater detail than the last video. Secondly, I rewrote the system from the ground up using scene graph. Currently, scene graph does not work with Fortnite props or fab assets. Until Epic exposes them as their own component, for example, it is not possible to use Fortnite props without ripping them from the game. So, just use your own assets. In this video, we will briefly go over scene graph for those who are uninitiated. After that, we will look at the code of the custom player, with inputs and the new pickup function. And finally, we will look at the updated custom item class, new inventory class, and the editor assets you need to make for each item. So, what is scene graph? At its core, scene graph is still a hierarchical framework where game objects have parent-child relationships. It's not anything new. The Unity game engine already implements this. As a component-based object system, scene graph allows components to be queryable up or down the relationship tree. But it is more powerful than the actor blueprint system because you can query global objects from nearly any context. Scene graph gives us access to some new classes, so let's go over what they're about. A prefab is a reusable asset, which is a collection of entities. Prefabs can only be created in the editor and show up in the assets.digest verse file as their own class. You cannot edit them in code for now. An entity is a class which acts as an empty container that can hold components and other entities as children. In the code, assets.digest generated prefabs are a subclass of entity. A component is a class and an individual part that makes an entity do things or be something. The intended purpose is to attach these components to entities as children. Components include things like a world location, a mesh, a particle system, a gameplay script, a light, a sound, and more. The image on this slide is an example of a prefab from the documentation. The whole house is a prefab. It is made of entities, such as the walls, floor, and roof. The wall entity, for example, is made of components. They would be a transform and a mesh. The wall entity would also contain the door entity as a child object. This door entity would have components including a transform, a mesh, an interactable component, and a verse script component to make it open and close. As you can gather, the advantage of scene graph is that you can create modular, reusable game assets. But more importantly, in the code, they are easily walkable and queryable from most contexts. To get a better understanding, you should watch this 2025 Unreal Fest talk on scene graph by Rodney Hewell on YouTube. Another great resource is the documentation on Epic's website, which is very extensive. Now that we understand more about scene graph, I'll do a demo on how pickups work in this system. Firstly, when the player presses the interact button, it triggers a scene graph entity sweep in the player's forward view direction for a certain distance. This function returns collisions with entities, which once filtered can determine hits with pickup items. The first pickup item hit is selected and the item reference gets set into the player's inventory map. The item itself gets moved to 000 and disabled, so no other players can interact with it. Then, the inventory item spawns the Niagara VFX for the player and also an entity for other players to see. To drop the item, this process is just reversed. Before I go over the pickup function code, let's look at the player. First, the game starts and spawns players on the spawn pad devices. The game mode manager is subscribed to the spawn pad's spawned event, which is subscribed to a function that validates that the player has been spawned successfully and is currently in the world. Then, we can make an instance of our custom player class, initialize it, and add it to a custom player's map in the game mode manager device, with the type player as the key. I like to initialize the player with things that do not change and that you will be referencing often, so you do not have to keep casting to get them. These being player reference, Fort character, Fort entity, an inventory class instance, and also the player input and UI devices. Moving on to the Fort devices for each player, I store them in a single creative device, so I can access them in the code from one reference. That also means I only have to pass one device to the custom player class. When the player validation function succeeds, an initialize function is called that subscribes other functions to events on these devices, such as an input triggered event. Now onto the pickup function. First, the player presses their interact button. For now, I have it set to pickaxe. The input trigger pressed event fires a helper function that checks whether the player is already holding an item. This check is a boolean or logic variable stored in the player class. If no item is held, it calls the pickup function. If an item is held, it calls a drop function. In the pickup function, first we update some variables that store the player view location and player view rotation. I use variables for these only because these values get reused a few times. Then, I create a displacement vector from the player's view rotation local forward unit vector to use in the entity sweep function. Next, I call the find sweep hits function on the player's Fort entity. If you read the definition of the function, it notes that the entity you call the function on is only used for the scene context and does not take part in the query. Since I have already stored the Fort entity and it exists in the right context, I use this one. The find sweep hits function takes a displacement vector, a starting transform, and a sweep object. For the first input, I use the displacement vector from earlier. For the second, which is the start global transform, I use the player's view location. This is the global location of the player's camera. Finally, for the physical sweep object, I use a collision sphere, which is a subclass of collision element. The function results in a generator of type sweep hit. Instead of using a for each loop to do something with the results, I use it to store the sweep hits into an array. I do this because I want to use a custom loop that breaks on a correct hit, so it won't keep iterating and doing unnecessary checks. In this loop, I filter hit objects by checking whether the entity contains a custom component, which only stores a unique identifier as an integer. The presence of this component alone qualifies an entity as a pickup item. When the first sweeped entity with this component is found, the loop breaks and calls a function to do something with the result. This function first moves the pickup item to 000, disables it, then fires another function that adds the item to the player's inventory class. Then, an inventory function is called that spawned entities for the player and others. After that, two more functions are called which sets their visibilities using the set presentable to players function. Now let's look at the inventory class. This inventory class is simply a glorified container for a map variable of the type of my custom item class. The key is an integer, which is the hotbar slot number. It also houses inventory-related functions. The only thing left now is to talk about the custom item class. What I came up with is a parent class that must be initialized with many values, and each item is its own subclass which overrides the parent class. When you create a new item, you call this special function with the constructor specifier. This is because it was the best way I found to set the default prefab instances for each item subclass. Now, to the editor assets. Each pickup item has 3 prefabs and 2 Niagara particle systems. Since we are using scene graph, the pickup items in the world must now be entities. The first prefab is for this world item. It only has a transform, custom component, and a mesh component. The second prefab is to show the item to the player. It has a transform and a particle system component. The Niagara system here is from the previous video, which uses the player's camera. The third prefab is to show the pickup item to other players. The Niagara system here is similar to the last, except the parts involving the player's camera are removed, and it just renders at the emitter's location. In the code, this prefab gets attached to the player's entity as a child object. It will move at the same rate as the player's entity. At the moment, the player entity appears to have the smoothest server-side replication. You can tell it's still limited by the 30-tick server, but the interpolation on the rotation is good, and the interpolation on the movement is the best we have to work with. And that's it. That's the fix for making your custom item, pickup, and inventory system work with multiplayer. As always, if you enjoy game development content, or you're making a game yourself in Fortnite, you can follow me on Twitter where I post tech updates like these. Thanks for watching, and I'll see you in the next video.